Hello friends, I welcome you all on my YouTube channel Abhijit classes. In today's lecture, we will be solving a problem based on rotational dynamics. Now, as you can see, the question is a plank of mass m with a uniform sphere of mass small n placed on it rests on a smooth horizontal plane. A constant horizontal force F is applied to the plank. Calculate minimum coefficient of friction between the sphere and the plank so that there is no slipping between the sphere and plank. So guys, this is the situation. We have a sphere of mass small n and radius r, which is placed on a plank of mass big M. Now a question is a constant force F is applied to the plank in the horizontal direction. Suppose this is the axis. So along the positive x direction, a force F is applied on the plank. We need to figure out the minimum coefficient of friction between the sphere and plank so that there is no slipping between the sphere and plank. There is no slipping between the sphere and plank. It means that it is a case of perfect rolling of the sphere, which means the point of contact has the same velocity as that of the surface, or acceleration of the point of contact is same as that of the surface. Now the sphere is resting on a plank, so if that plank is subjected to a force F, then due to the application of this force, an acceleration is produced on the plank. The plank is in pure translational motion, so acceleration of every point of the plank is same. Now according to question, sphere rolls on the plank. There is no slipping between the sphere and plank. It means the point of contact of the sphere has the same acceleration as that of the plank. If suppose A is the point of contact of the sphere, then acceleration of point of contact will be same as that of the acceleration of the plank. Suppose AP is the acceleration of the plank. Now guys, there is no slipping between the sphere and the plank. It means that sphere starts to roll. Frictional force will act in the forward direction. It tries to bring the point of contact of the sphere at rest with respect to the surface of the plank. So guys, frictional force will act in the forward direction at the point of contact of the sphere. I will show you with the help of animation that how the things are working. So this is a plank. Now if a force F is applied on the plank, then what happens? Have a look. I'll show you again. So two things are happening, guys. If you look at the sphere is rolling, an angular acceleration is produced. Also the center of mass of the sphere is displacing in the forward direction. It means that there is a translational acceleration. There is an acceleration of the center of mass. So it has an angular acceleration as well as a translational acceleration, which is the acceleration of the center of mass of the sphere. So guys, if I draw the free body diagram, of the sphere, it will be like this. As I said, the point of contact is at rest with respect to the surface of the plank, so frictional force will act in the forward direction. Now what other forces are acting? An mg force and a normal reaction. There is an angular acceleration. An angular acceleration will be in this direction, will be anti-clockwise. And also there is an acceleration of the center of mass of the sphere. Suppose AS is the acceleration of the center of mass of the sphere. Now if I write the equation of force for a sphere, I can write that F is equals to mass times acceleration of the center of mass of the sphere. Suppose this is equation number 1. And if I write the equation of torque about the center of mass, if I write the torque about point O, you know that the radius of the sphere is r. So torque about point O is torque about the center of mass is equals to Fr Also, torque about the center of mass is equals to moment of inertia about the center of mass multiplied by the angular acceleration produced. Therefore, we can write Fr is equals to ICM alpha. Now guys, Fr is equals to ICM is the moment of inertia of the sphere, which is 2 over 5 mr square alpha. Alpha is 5f over 2 mr. Suppose it's equation number 2. Then for Planck, the mass of the Planck is big M. The forces acting on the Planck are, if I draw the free body diagram of the Planck, guys, have a look. This is the Planck. Now the force F is applied on it. So suppose AP is the acceleration of the Planck. Now the forces acting on the Planck are mg, the normal force from the bottom surface, and the reaction of this normal force is on the top surface, which is n, and the frictional force at the point of contact of the sphere is acting in the forward direction, then its reaction will act in the backward direction on the top surface of this Planck. So guys, we can write that, so F minus F, this is for Planck, F minus small f is equals to mass times acceleration. Suppose this is equation number 3. I will show the question again. This is the case of perfect rolling. There is no slipping, as it is written that there is no slipping between the sphere and Planck. It means point of contact of the sphere is at rest with respect to the surface. Suppose A is the point of contact of the sphere. Now what is the acceleration of the point of contact? Acceleration of point of contact of the sphere is A. As you can see that the pure translational component is AS in the forward direction, and the rotational component alpha r, which is alpha r is also in the forward direction, so AS plus alpha r. Acceleration of point A is AS plus alpha r. It is greater than that of the acceleration of the center of mass of the sphere. Now carrying the question, since point of contact is at a rest with respect to the surface of the Planck, it means acceleration of A is equals to acceleration of the Planck. There is no relative motion between the point of contact and the surface. So it means it is a case of perfect rolling, since relative acceleration is 0. Therefore, we can write that AP is equals to, okay, I will write it over here. Therefore, AP is equals to AS plus alpha r. AP is equals to AS plus alpha r. This is equation number 3. Suppose equation number 4. If you combine these 4 equations, equation number 1, 2, 3 and 4 from equations, therefore from equations 1, 2, 3 and 4, we can write that. So you can substitute the value of AP from equation number 3 in equation number 4. We get F minus small f over capital M is equals to AS is F over M from equation number 1. Now alpha R from equation number 2 is 5F over 2M. Now guys, we need to figure out what is the minimum coefficient of friction between the sphere and the Planck, so that there is no slipping between the sphere and Planck. We need to figure out what is the minimum coefficient of friction. So let us first find out what is F, small f, which is the frictional force. So from here we can write that this is equals to 7F over 2M. So F minus small f over M is equal to this. Therefore, F is equals to 2mf over 2m plus 7m. So this is the frictional force. Since you know that frictional force is less than the maximum value of static friction, which is mu n in case of perfect rolling. For perfect rolling, frictional force is less than the maximum value of frictional force, which is mu n. Therefore, guys, we can write that 2mf over 2m plus 7m is less than or equal to mu n. Now n is equals to mg. If you see the free body diagram of the sphere, there is no motion along the vertical direction or y-axis, right? This is the axis, suppose x and y-axis. So there is no motion along this direction, so you can write n is equals to mg. So mu mg. Therefore, now you can see that m cancels each other. So guys, mu is greater than or equal to 2f over 2m plus 7m multiplied by g. So guys, from here you can see that I'm putting star mark over here because the space is not available. So I'm writing it here, the answer. Therefore, mu is greater than or equal to 2f over 2m plus 7m multiplied by g. So the minimum coefficient of friction between the sphere and the plank is 2f over 2m plus 7m multiplied by g. So guys, this is the answer. So friends, you have seen that in this lecture we have discussed a problem which was based on perfect rolling. You need to simply draw the free body diagram. You need to visualize the situation, draw the free body diagram, and then write the equation of force, equation of torque, then apply the condition of perfect rolling. You'll get some equations, and with the help of those equations figure out F. Then for rolling, always remember that frictional force is less than the maximum value of static friction, and then by substituting the values you can get the coefficient of friction. So guys, if you like my video, please subscribe to my channel Abhijit Classes, and do press the bell icon to get every notification related to my physics videos. Thank you for watching.